So I just wanted to make some additional comments about your course project since the proposal is due on Friday. So first, in terms of which system you choose to study, here are ones that I'm just going to ban as too simple, or just that wouldn't be interesting. So don't choose this. This is like the first differential equation we looked at. This is just a little bit too simple of a start. And don't choose anything like this. X prime equals some function of t alone. Also, don't choose something like this. Any number of derivatives equals a function of t alone. Because then it's basically just an integration problem, right? Which is, you can still apply our theory, but it's just less interesting. Okay, so don't choose things like this. Do choose something interesting. That's the most important. That you choose something interesting to you. And, last time I said something like, choose something relevant to your major. That's not always easy, but maybe I should say more important is choose something that you find interesting. Often, studying a problem in depth can improve certain skills and help you in certain ways that are not going to be clear to you yet. So choosing something outside of your major doesn't necessarily mean it's not going to also help you. But definitely choose something interesting. And also, do not be afraid to look at second-order differential equations. So that is definitely an option. A lot of the options I listed for you guys are first order in the list of exercises where you can get some ideas. Those are all first order, but there are also some second order things, and those are the things we're looking at this week. So those are not. Those are also going to be interesting, and not necessarily much harder to analyze. So yeah, if any of the stuff we're doing this week is interesting to you, feel free to pick one of those systems. So there are sort of these four elements to the project. The proposal, where you describe the system, the analytical work that you do, or what I refer to as the theoretical analysis, the numerical work that you do, and then your deeper look, which I included as what you should add to your final write-up at the end. And then these will all be packaged together in the final write-up. And they'll also be packaged together in the presentation. And the deadlines, so there's a deadline at the end of this week for the proposal. So let me put blue dots for deadlines. There's a deadline for the analytical work. There's a deadline for the numerical work. So these are three things that you're submitting at different times. And then there's a deadline for the final write-up. And then there's a time period where you select slots for presentations. So what I'm trying to alert you to is that you have a lot more time, actually, for the deeper look portion towards the end than you have for these individual things, which have these quick deadlines. So what I'd suggest in your plan is allow yourself to do something simple. For this portion. Allow this portion to be simple. That is totally okay. Don't worry about trying to pick something complicated, very complicated, just to make it super interesting. Because if you have something complicated in mind, then you can incorporate it into your deeper look. So for example, if you have, a sort of complicated differential equation and a simpler version with a lot of simplifying assumptions in it, then choose to propose and work on the simpler version so that you can definitely get this work done, and so that you can allow yourself to save the more complicated parts for this deeper look. For these kinds of things, we'd like you to actually be able to do it. So if you pick an impossible problem, that would be bad. You should be able to carry out some kind of analysis, theoretical and numerical. So pick something simple enough that you can. It's okay if it's just a step above, just one step above these terribly simple examples. For this, on the other hand, you're not as much going to be graded on like whether you were able to complete a thorough analysis or not. This is where you can be more creative, you can be more risky and try something, and if it fails, then you can write about what you tried and why it failed, and that would be sufficient. So play it safe for your initial project and save the complication for later. But don't play it so safe that you're doing something stupid like this. Oh, and also, if you have not looked at the Gaucho Space page for the course project, definitely look at that. I give you a bunch of suggestions there for where to pick examples from. And again, since I'm saying you can feel free to play it safe for this portion, it's totally fine to pick something where you can see the solution right there, in the solution back, in the you find an online solution or something like that. There's nothing wrong with that. The point of this is that you're writing up your own explanation of how to do it. So this is not like web work where we're testing you like, oh, can you solve this problem? This is more, get the solutions one way or another by someone else solving it for you, fine. But can you understand and explain it and write about it competently, showing that you understand what's going on? And then at the end, maybe when you're doing this part and wrapping up your final write-up and making your presentation, that is where you might introduce more of your own insight into the situation.